All right, welcome to Lecture 3, Part B. And on this one, we're going to talk about a big topic, something you're going to be hearing about a lot this semester, and that is units and converting between units. So with that, let's go ahead and get into it. Okay, let's start off by just talking about units. Now, when we do problems in chemistry class, we're not going to use the units you hear most in your everyday life, right? We're not going to use yards and feet, and we're not going to use quarts and gallons. That's sometimes called like the English system, and that's what we use, commonly around our house. But in science, we like to use the metric system. So we're going to be using the metric system most of the time this semester. Now on this chart, I've listed like 4 things that we commonly measure, and I want to make sure you know what unit we would use for each one of these. So often in class, we're going to start off by measuring maybe we'll worry about mass or length or volume or temperature. I want to make sure you know what units we use for that, the metric units. So to start off with, for mass, the unit in the metric system for mass is grams. Now, often we're not going to write out the word grams. We're just going to use the symbol for grams. The symbol for grams is little g, little g. Little g, that was actually my rapper nickname for a while. No, I'm just kidding. I was never a rapper. I don't have that kind of talent. All right. But if I ever was a rapper, I think I'd go by Little G. I like it. It has a good ring to it, if you ask me. All right. So what the heck is a gram? A gram, if you get a paper clip weighs about 4 or 5 grams. So a gram ain't much. All right. So this is more than a gram even. It's a few grams. All right. What other things do we typically measure? We typically also measure length. So how long things are. Not going to do that in feet, not going to do that in yards, not going to do it in miles. We're going to use meters. And what is the symbol for meters? Little m, lowercase m. All right, volume. Not going to use quarts and gallons and pints very often. Usually we'll be measuring volume in liters. And the symbol for liters is a capital L. Now, as far as temperature goes, our last common thing. For temperature, the way that we measure temperature, it's not Fahrenheit and it's not even Celsius. You might have heard of Celsius before. The one that we typically like to use in chemistry class, is Kelvin. All right, what is Kelvin? We're going to talk about Kelvin and other temperature units in a future class. The unit, or the symbol I should say, for Kelvin is a K, capital K. By the way, there's no degree sign. It's just a capital K. All right, so there are going to be other units we're going to run across, but the units, the other units that we typically run across, it turns out, are usually made up by just combining these units. Like, so for example, and maybe I should write this up here. We'll say units can multiply together to create new units. So like, for example, let's say you wanted to measure the area of something. I got this box of cereal here. It's morning. I'm doing this in the morning. So I got my box of cereal. And let's say I wanted to know the area of the box, right? Like how big is this picture, all right? This total box. All right, if I wanted to measure the area of this box, I feel like I'm hiding behind it. Hi. All right, so if I wanted to measure the area of this box, the front of this box, the way I would do that is the formula for area is length times width. So I might measure how long this thing is and then how wide it is, and I would multiply it together. Now again, let's kind of think in terms of the metric system. And this is actually going to be way bigger than that box, but let's just say maybe this would be like the area of a floor, like you have you want to put down some carpet or something, and the room is, I don't know, 8 meters long, and it's 6 meters wide, If you want to know the area of that room, the floor, like how much carpet it would take to cover it, if I want to know the answer to that, I would multiply the numbers. 8 times 6 is 48. By the way, that's rounded correctly, isn't it? Yeah, we always got to check our rounding. And then not only would I multiply the numbers, I would also multiply the units. So a meter times a meter is a square meter. A meter times a meter is a square meter. Okay, with that, what about another example? What's another unit that we might come across that's really just these units put together? Well, another place where this happens is for volume. So again, let me look at my total box here. If I want to know the volume of it, like what's the volume of this box? How big is it? The way you measure volume, and I'll put it over here maybe. Volume is length times width times height. So I get out my box of cereal and I measure, let's see if I can hold it back, it'll be easier. I measure how long it is, I measure how wide it is, and I measure like the depth of it, the height of it. So you'd measure all three of these directions. You'd measure this way, you measure this way, and then you would measure the depth of it. And if you put that together, length times width times height, that's the volume. So let's just pretend, for example, that the box was 10, and actually maybe instead of using meters, another unit of length that we'll run across is centimeters. Let's say it's 10 centimeters long, and let's say the width was 5 centimeters, and let's say the height was 3 centimeters. Well, if you multiply all those together, yeah, we're going to get the number part of the answer, and 10 times 5 times 3 is 150. But I also want to know the unit part of the answer. So just like I did a minute ago, we can multiply the units. So a centimeter times a centimeter times a centimeter, if there's 3 of them, a centimeter times a centimeter times a centimeter, that's going to be a cubic centimeter. Okay, so it would be 150 cubic centimeters. Now, one other thing I'll tell you about this is that cubic centimeters sometimes has another name. Sometimes instead of saying a cubic centimeter is the same thing as a milliliter. All right, same, that's an A there, same as a milliliter. So it turns out 1 cubic centimeter is the same thing as 1 milliliter. You might even hear it called CC, like if you've watched medical shows, or some of you guys and gals might work in hospitals or hope to work in hospitals. So a milliliter, a cubic centimeter, that's the same thing as a CC, right? They'll say, oh, give them 50 cc's of adrenaline. It's 50 milliliters, really, same thing. All right, it's also the same thing as a cc. All right, a cubic centimeter. Okay, with that, let's get to converting. Now, actually, before we get to converting, let me show you one more thing. Let me flip one more slide here. There we go. All right, so a little glitch in the switch in there, which is when we convert, converting just means go between different units. So to be able to do that, you're going to need some information typically, and that information is how those units are related. So on the same module, there should be a link that says conversion factors. That's this handout that you see on the screen right now. If you have a way of downloading it and printing it, you're going to want to print it because you're going to use this for a while in this semester, okay? So you want to go ahead and download and print it if you can. I'll try to show you on the screen when we do problems, but it's actually going to be easier to have it in front of you. It'll be easier to read. So this lists a bunch of ways different units are related, like miles and feet and other units. I should tell you, this handout, for the time being, we will not do any problems with pressure. So I'm going to ignore this part of the handout for the time being. Eventually, we will talk about pressure. Pressure has to do with gases. Gases we don't get to for a few weeks or a few months, actually, a couple months. So we will use the bottom part of the handout eventually. But mostly right now, we're going to focus on the top section. So see if you can find that handout, print it out, keep it handy. You're going to use it a bunch in this section of the class. Okay, with that, let's get to an actual converting problem. Okay, let's start off with an example where maybe involving time. That's another unit that we might convert between. So let's say, for example, I don't know, you like to make your breakfast in the morning, and when you make your breakfast in the morning, you always like to cook an egg, and it takes you, let's say, 2 minutes to cook your egg. 2 minutes. So if I told you it took you 2 minutes to boil your egg or whatever, and I wanted to know how many seconds is that, that's a conversion problem. 2 minutes, how many seconds is that? Now, you might be able to do that in your head, right? You might be able to go, oh, I know the answer to that right off the top of my head. 2 minutes is however many seconds, right? Now, that's great, but really what I want you to focus in on is not so much just coming up with the answer. Now getting the answer, that's super important. I'm not saying it's not important. But beyond that, what also is going to be important for you is learning how to set up problems the way I'm about to show you. Because pretty much every time we do an example in this class, whether it's in this chapter or in a chapter 2 months from now, we're going to be setting up problems the way I'm about to teach you, okay? So learning this method is super important. And when you turn in work to me, if it's written work, I'm going to want to see this work the way I'm about to show you. I don't really want to just see the answer. I'm not going to give you credit for just the answer. I want you to show me the work the way that I'm about to explain it to you. All right? So let's say again we had 2 minutes. I want to know how many seconds that is. So the first thing I'm going to do is I'm going to write down the beginning and ending unit. And I should also mention, we will leave a little space between them. Now, in this example, I'm already giving you the beginning and ending unit, right? I told you we're going from minutes to seconds. So minutes is my beginning unit, seconds is my ending unit. Now, that's great. In this case, I've told you what those units are. Maybe in another problem, I don't tell you the unit. I might just say, what is the mass of something? And you have to know, oh, if he's asking me for mass, I need to solve for, I'm solving for grams. So grams would be my ending unit. Or I might say, what is the volume of something? And you would have to know, oh, I am solving for liters. Liters would be my ending unit. So for right now, I'm just going to give you those units. Maybe in the future you'll have to kind of come up with the units a little bit on your own. All right, so let me go ahead and do that part of the work. I'm going to do it right here. 2 minutes is, and I'm going to leave a little room, like I said, and I'm going to write equals how many seconds. All right, step 1 is done. Write down the beginning and ending unit, leave a little space in between. Step 2, write, or I guess we'll say determine a conversion factor. Determine a conversion factor. So a conversion factor, again, is just how those ideas are related. Most likely, you're going to find them on that handout I just gave you. I would encourage you to get used to use that handout because that's going to be really useful for you. So on that handout, again, it lists all different ways that different units are related. Now, in this example, the conversion factor isn't actually on this handout. You probably just know it off the top of your head, right? If I asked you how are minutes and seconds related, that's what a conversion factor is, you would be able to tell me, oops, excuse me, let me switch colors here. You would be able to tell me that 1 minute is 60 seconds. 1 minute is 60 seconds. So that idea that maybe you just know off the top of your head, or maybe you look up on that handout I just pointed out to you, that idea is your conversion factor, all right? So 1 minute is 60 seconds. Step number 3. Step number 3 says, use that conversion factor. Use the conversion factor so that all the units cancel except the one you want. All right. So a minute ago, we talked about how units can multiply together. Well, that's totally true, but besides units multiplying together, units can also divide out. And we're going to use that fact to cancel out units until we end up with the one that we're trying to get to. Now, let me kind of explain that to you with this example. So, for example, what I would do here is in the middle, I'm going to put a conversion factor. I'm going to put my conversion factor, and one side of it is going to go on the top, and one side of it is going to go on the bottom of this like line I've put in. Now, the way you know which goes where is you look at your units. Now, if you have minutes to start with, right? We have minutes to start with, and we want minutes to cancel. The way that we would make something cancel is you put them in opposite blanks. If something's on top and the same thing's on the bottom of like a fraction, it cancels out. Well, that's true with numbers, and it's also true with units. So if we want those units to cancel out, and I'm starting off with minutes, the way you make it cancel, you put it in the opposite blank. So in the middle here, I'm going to be using this conversion factor. And the way I use it exactly is if I have minutes here, I'm going to put minutes on the bottom, so minutes goes away. And soon as you write minutes on the bottom, look at that conversion factor, and right next to the word minutes, there's a 1. So we'll put 1 on the bottom as well. So the unit stays with the number. Wherever you wrote minute, you're going to also write 1. And then the other side of the conversion factor goes on top. So that would be our 60 seconds. So 60 seconds should fit on top. Now, if I work it out, the way I would work this out is I would do 2 times 60 divided by 1. And you can do your calculator, or you might even be able to do this in your head. 2 times 60 divided by 1 is 120. Now, let's just double check. Does that look right? So one thing that should be true again is our unit should cancel. Minutes are here. Minutes is on the bottom of the next step, so it cancels out. That's always going to happen. Whatever unit you're trying to get rid of, you'll put it in the opposite blank, so it goes away. And then the other thing that you're always going to want to check is you need to make sure your answer is rounded correctly. So let's just confirm that. Now, conversion factors are considered exact values, which means that we're going to ignore them for rounding. So really the way this is always going to work out is however many sig figs I gave you in your beginning number. Let me switch here. However many sig figs I gave you in the beginning number, that's how many you're going to give me in the answer. Conversion factors are exact numbers. So what that means is we ignore them for rounding purposes. We ignore them for rounding purposes. So I gave you again 2 sig figs, right? Because that trailing 0 with a decimal counts. And when I was done, I actually did it correctly. This number also has 2 sig figs. So however many sig figs you start with, that's how many you're going to give me in the answer. All right, so this is converting. Now, again, maybe this isn't the hardest problem, right? Maybe, like I said, maybe you could do this in your head. More important than this is we are going to get to harder problems. So you got to learn this method to help you, because when you get to other problems that are a little more complicated, if you understand this method, you can do a really challenging problem. And like I said, we're going to use this method all semester. So getting familiar with it as soon as you can is going to be really important for you. All right, so let's go on to another example. Let's do an example with mass, okay? So let's say you knew how much you weigh in pounds, and you want to figure out how much you weigh in kilograms. And actually, again, some of you guys and gals might be trying to go in the medical field, and this is often actually what they do in the hospital, right? So they'll ask you your weight when you come in, and then actually they want to know the weight often in kilograms, because when they decide how much medicine you need if you're not feeling well, often they'll give it to you on a per kilogram basis. So they want to know how many kilograms you are to see how much medicine you need, maybe to help you out. All right, so you go in the hospital and you say, "Oh, doctor, I weigh," and let's actually use my weight. So let's see, I wonder what I weigh. If I stepped on a scale right now, let's look. Look at all this muscle. I weigh a lot. Oh my God, look at those. Okay, maybe not so much, huh? Oh, I weigh about 167 pounds actually. So if I weighed, my scale said 167 pounds, and then I check into the hospital because I'm not doing so good, and they want to actually know my weight in kilograms, how would they do that? How would you go from pounds to kilograms? All right, so first thing I'm going to do, we got to get good at these habits, right? So one thing that's going to help you all semester is habits, good habits. Don't try to do stuff in your head. Don't try to figure it out some other way. I'm telling you, this is the way to get it done. Step one, write down your beginning number and unit. Write down the unit you're trying to go to. 167 pounds is how many kilograms? In the middle, we're gonna, in a minute, put a conversion factor. Half of it is gonna go on top of the line, half of it's gonna go on the bottom of the line. So step two is find that conversion factor. Determine that conversion factor. Might know sometimes in the top of your head, you know it. Often, you're gonna look it up on that handout. So if I look it up on this handout, there is one that helps me out actually. It's the last one down here. 2 pounds is 1 kilogram. So that's the one that I'm going to be using. 2 pounds is 1 kilogram. There's other ones, but this is one that goes from pounds to kilograms, and that's exactly what I'm doing. Let me write it down here so you can see it a little better. 2.2 pounds is 1 kilogram. So what I would do is, now that I know how these units are related, I'm going to get my unit to cancel, the one that I don't want, by putting in the opposite blank, and I'm going to hopefully end up with the unit I do want. So to be exact in this example, if you start off with pounds right here, where does pounds need to go to cancel? It needs to go on the bottom. If you put pounds down here, it would cancel out. So you're going to put pounds on the bottom, go away pounds, and there has to be a number down there. What number? Well, the number you see next to the word pounds in the conversion factor. The 2.2 is going to go on the bottom. So we would put 2.2, wherever you write pounds, the number stays with it, the 2.2 stays with it, and then we'll put the 1 kilogram on top, 1 kilogram on top. All right, it should look like this. All right, so if we work it out, let's say, oh, first off, before we work it out, is this set up right? I think it is, because pounds are here and pounds are here. And if they're on opposite blanks, it should cancel, right? Opposites cancel. Same thing on top and on bottom, that's going to cancel. The only unit I'm left with is the one I want, kilograms. So yeah, this looks set up right to me. So now we can actually do the work, all right? So I'm going to bust out my calculator. 167. And then what you would do is you would times it by 1 and then divide by 2.2. Now, timesing it by 1 doesn't really help you much, right? It's not changing it. So let me go ahead and divide by 2.2. And your calculator, I'm going to write out the entire answer so you can see it. It's going to be some ridiculous number of digits. 90909, keeps going. All right. So, wow, calculator, don't do that to me. You got to round it to sig figs. And actually, that's going to be where you come in. So how would we round that correctly? Remember, conversion factors are exact numbers. Don't think about them when deciding how to round your answer. The way you decide how to round your answer is going to be based on the original number. This number right here has 3 sig figs. So the way I would get 3 in my answer is I would take this and I would round it to 75.9, I think. That would have 3, 75.9. Okay, 75. So I weigh about 75.9 kilograms. Let me check my notes. Is that what I got? Yeah, that's right. Okay, so that's it for this. Now we're going to move on to another part of this lecture. So there's going to be another video on converting. So we'll do another few examples and get into some that are a little bit more complicated. So let's go ahead and stop this one and we'll move on in a minute.